And recording has started. I actually don't know where the recording goes to, so we'll figure that out later. It is my absolute pleasure to welcome you all here to this first panel discussion for the panel event. I guess this is the 4 talks that were the opening morning talks for the workshop, the VizWiz captioning workshop. So I have the pleasure, my name is Ed Cutrell. I'm one of the workshop organizers. I am a researcher at Microsoft Research, and I work in the ability team at MSR, where we basically are researching technology for disability and accessibility. And it's my pleasure to introduce, let me pull up all of my good introductions here, the 4 people who gave the talks that were recorded, and hopefully you've all watched those talks because that's what we're going to be talking about today. The first person I want to introduce is Meredith Morris. She's a senior principal research manager at the MSR Ability team. She's my boss, and she's at Microsoft Corp. Next, we have Anirudh Cole. He's the head of AI at IRA, and he's the ML lead at the NASA Frontier Development Labs. Next, we have Chicle Asakawa. She's an IBM Distinguished Service Professor at CMU, and she's also an IBM Fellow with IBM Research. She's one of the OG folks in accessibility going back for a long time. It's great to have her here. And finally, we have Sherry Azenkot. She's the assistant professor at Cornell Tech, Cornell University. And the 4 of these folks just did some, I think, fantastic talks and presentations about work with using AI and computer vision in captioning and generally sort of assistive technology. So I want to maybe start out with just a couple of quick questions. And if folks in the audience have particular questions, please add them to the chat. And I'm gonna hopefully depend on maybe panelists or Donna or somebody to maybe flag if they see a good question to just interrupt and let us know that there's a good question there in the chat. So the first question for the 4 of you, first off, welcome everybody. And I'm gonna make sure that everybody, okay, good. It looks like we have all the right folks here. The first question is that in all of your presentations, context seems to be really important, whether in captioning, in navigation, object recognition, etc. And so I'm just curious for each of you, what does context mean? And how would you operationalize or use this kind of thing in a system that are used by people who are blind or low vision? Should context be automatically inferred, or are there times it should be explicitly articulated by users? And so I'll open that up, and maybe we can start with Anirudh since he starts with A.
Yeah, let me be the guinea pig here. So I think I have a story in this particular case. And the story is that one of the apps my teams previously worked on was at Microsoft called Seeing AI. And Seeing AI basically is a Swiss Army knife of computer vision tasks. So whether it's like recognizing currency, whether it's reading, whether it's understanding documents, and a whole bunch of things, even like understanding how much light is in my room. So you can come up with audible sound. So converts vision to audio for people to do things. And so set 9 to 10 very specific, hyper-specific tasks is what it does. So the next question was, won't it be good to have like a God mode in it, where you just hold your smartphone camera and it understands what the task is that the user has, and it gives you the answer. It sounds a really good idea on paper, but the number of conflicting intents that a single image can have is just high. For example, you might have a currency node, and that's kind of pretty clear. You're trying to understand, is this, which particular currency is it? But then there might be things where you're taking a photograph and there is text behind. So is the person trying to read, or is the person trying to understand the general scene? There's a particular mode where you can do object understanding, and then you can use your fingers and explore over it to discover where on the screen is the particular text. So it gives you some sort of a location. And is it a particular form of, like a form that you're trying to understand where the text is located, or are you trying to understand what this particular object is that you can't touch because it's a little bit far away? Those conflicting things kind of made this God mode kind of almost hard to build. And so we went like back and forth, and just decided right now is not the time. We can build rules that, okay, maybe this is a currency, but we haven't trained it and we want to understand the text written on it. But the number of rules that we would have to build would just be too high number. So intent understanding, context understanding is really hard. So what we did is we said, look, the user, let them be the judge of what mode they want. Sure, there is a little friction, but they will be in control, and let's just depend on the user to tell us. And that has worked out fantastically.
Very cool. Let's go with Shiri next. What do you think?
Sure. So I think, yes, context is very important, as you said. In my talk, we were doing a project that had to do with people browsing their local photos to decide which and whether they wanted to post anything onto Facebook. So that was the particular context I was referring to in my presentation when we did our study. And I think that what that means, the way it can be operationalized, is first of all, thinking about the user, right? This is something that I don't see computer vision researchers really putting much thought into when they're collecting data sets and evaluating algorithms. So number one is the user. Number two, I think, is something that also needs to be broken down, and that's the use case. So where is the user? What is the user trying to do? In human-computer interaction, one of the things that we do is we draw storyboards to describe use cases, to show use cases. And so the storyboard should show who's the user, what are they doing before they use the app, what's the task they're trying to complete with the app, and then what happens after. So I think that that's a useful frame for thinking about context, at least as a starting point.
Cool. Let's go with Chicle. Can you talk a little bit about context?
Yes. So I really think, the context, understanding the context is very important to achieve the higher accuracy. However, currently, if we the system try to, understand the context, it fails because of the lack of algorithm or lack of data set. So, but in the future, I really hope, the system can understand the context much better than now. But we don't want to wait until, everything can be automatically inferred. So like today I talked about the personal object recognition or navigation system. These systems, work. However, we need to give the system the context. So we provided the way to tell the system what the context is right now, or give more data specifically related to users or use cases. So, so currently I'm taking two approaches, but in the future, if the system recognizes the context, that will be great. But until then, I think we should, take different approach.
Okay, very cool. Mary, the last one here.
Yeah, I think there are three kinds of context that might really influence what the description of an image should be. So one is the context of the kind of media in which the image appears. So you can imagine that the very same image might need a different alt text depending on if it appears on social media versus in a newspaper versus in an electronic textbook. The second kind of context that I think matters is the context of the task that the consumer of the image is doing. So for example, are you reading an article or electronic book to study for an exam for university? Or are you casually reading that same material just for entertainment? And that might change the amount of detail that you want in the caption. And then I think the third kind of context that matters is personal context about the user themselves. So for example, if I'm the consumer of the image, maybe I'm particularly interested in fashion, so the clothing of subjects in the image should always be described in detail to me. Or maybe it's personal context about my past interaction with that same image. So if this is the 4th time I've consumed that same image, maybe I get a more abbreviated version of the same caption for efficiency. So, so the kind of media, the task at hand, and characteristics of the individual end user, I think, are all really important kinds of context for image descriptions.
Excellent. All right.
Can I add? Can
Absolutely.
I just add to that? Yeah, I agree. I think those are all great answers. And I wanted to add that I think that context should be inferred, touching on what Chieko was saying, and also touching on what Mary's saying. There are lots of different types of information or sources that, you know, an algorithm or a computer can get the context from. And I think that it's very important to have transparency. So we should strive for automation, for this automatic inferral of context. But at the same time, I think it's really important to keep in mind that we should maintain the transparency of what the computer thinks the context is and how it's getting that information, or where it's getting the information to make that assessment.
Yeah, I think that's a really good point, Shiri. Yeah, I agree.
Well, so actually that notion of transparency leads us into a question around trust. You know, trust in the information provided by different systems is something that came up several times in your different talks. And so the question here is, in your opinion, what is the best way to manage users' trust? Like, is there a way to shrink the wide range of perceived accuracy across different users that Shiri talked about? And can we get beyond, like, image may contain blah, or there's a 90% certainty about blah? That, like, what else might issues of trust become important, and you know, how can we manage these issues? So I'm going to leave this open. Whoever would like to talk first should just speak.
Yeah, I have some thoughts on this. So the first thing I want to say is that we need to think about this word trust a little more deeply, right? Because the AI is going to make mistakes. And sometimes even the word mistake needs to be thought about more critically. But I think that we need to be careful, because we don't necessarily want to achieve just trust in the algorithm. What we want is to create some sense of understanding how much you should trust the algorithm, right? Because in certain cases, it's going to be unreliable. And so you want the user to be able to detect those cases so they won't falsely trust that information.
I'll add a comment there. I think a lot of times right now, the conversation around AI and computer vision is around how to get people to trust AI systems more. And I think that in particular, when we think about an audience that can't always verify the output of the system with their own senses, as is the case in image descriptions that might be consumed by people who are blind, we might want to think about the issue of trust from the opposite perspective, which is how do we make sure that our AI systems encourage a healthy amount of skepticism in the end user, so that people aren't overly trusting of the technology and are mindful of the fact that AI technologies will always have error in them, no matter how good they get.
So I have a question actually following that for the other panelists. And do you find that people in your research are placing too much trust on these AI systems?
I can answer, on both sides. Seeing from production. So when we are working in the Seeing AI team, when we are releasing it, there is a healthy battle between how you do marketing. So we basically wanted to go, under promise, over deliver. But the trust is the problem with something like image captioning. When you're trying to convert, we know from the get-go that this won't nail down every statement correctly when it's doing the captioning. So some modes were as accurate as possible. Like for currency recognition, you can't be less than 99.9%. You have to keep that precision, while maybe reducing the recall. So, you have to make that bet. You can't say $100 note is a $10. That would be just end of the day, your app will be used. Same like be good at text understanding. So keep many things which have a very high precision. So people will at least find, okay, they have something out there which we can use and we are finding it useful. And then for the other things, make sure that you claim it like this is like a 3-year-old, it's still learning, it's still experimental, have the right wordings for it. And what we noticed is that people, because they had the skepticism even in the literal documentation, even before you open it, and because it was not marketed as it does something amazing, it just said that it has a feature still in experiment. They played with it, they tried out on things that they knew what the answer was independently. And the comments that came were actually not negative, but instead they were like, when it works, it's magical. Like that was one of the first sentences we heard. And that kind of brought a smile because people were taking exactly the message in the way we wanted to tell them. If instead it was, one of those flashy newspaper headlines, which we all hate, blah and blah has a third eye kind of a thing, which I mean, you might have, heard about before, that would be pretty bad. So if from the get-go, you speak about it with that skepticism in your own documentation so that anybody else who's going to relay your message will try to be at the similar level, I think it works in benefit for everyone. Yeah.
So I have some thought about the accuracy of AI systems. So I am a researcher, and I'm a blind myself, and I'm a researcher in accessibility. So whenever I discuss with AI researchers or developers, they tend to say that the system accuracy is not there yet, maybe 70% or 80%. Sometimes it makes mistakes. However, and they say maybe it may not be useful for the blind people, but I could say as a blind person's perspective, still it's useful because even it has only 70 or 80% of accuracy, we as a human being can fill the gap. So if the system says something completely wrong, we could figure out it may be wrong and we can try to find out what it is. So I think here we accessibility researchers and users should have an important role, when the system, AI system, we can start using it. So, so I really think, 100% is ideal, but it's not there, but we don't have to wait. We can sometimes trust people. That's my thought.
Cool. There's a follow-up question from the audience. This is from Lauren Olson, having to do with trust. And she asked, would you see adapting trust and acceptable error rates to scaled range based on the domain of questions? So I think this is getting something like what Anirudh was talking about, where medication health questions or currency, for instance, might be more important to strive for higher accuracy and convey more skepticism where high accuracy isn't possible.
Yeah, I think I'll give a very quick answer that some things can be life-threatening if you do it the wrong way. Other things are sort of okay, and people are okay with it being somewhere. So the two parts being yes, depending on the task, it would matter. For example, if you are making a navigation system, and in the middle somebody has kept a wet floor sign, and you forget your technology does not actually figure that part out, that can be something which will put somebody in harm's way. So depending on the thing, those things should be higher priority when you're building your particular task. That comes into mind. Second thing I will very quickly mention is there's the concept of model cards. So there's a paper by Margaret Mitchell and Timnit Gebru called Model Cards for Model Analysis. It's kind of like a LinkedIn profile for your models that you're releasing. And in that, it specifically says all the things that's missing out on the potential risks, so that anybody who reads it, even a normal journalist, can actually capture that information right away. So being transparent on that would help. Yeah.
Anyone
I was
else?
going to add something. I think two things actually. So first, I think yes, definitely, different error rates for different situations might be acceptable. And I think Chaco had a really important point that determining what those thresholds of acceptability are is something that the target and user community should have a say in. But the other thing I wanted to mention is I think one challenge there is that these confidence thresholds themselves are in some sense somewhat arbitrary because they're constructed in a way that doesn't necessarily correlate with like a human understanding of what the mistakes are. So to give an example that wasn't in the talk I gave for this workshop, but that I use in other talks, there's a photograph that my friend took of me a couple years ago where I'm attending a 4th of July parade. And so I ran that photograph through one of the state-of-the-art vision to language algorithms, and the automated caption it produced was, a woman, smiling and confidence, 100%. Right? And it was true. I am a woman and I was smiling in the picture. But what the caption left out was it just failed to mention at all other very important information in the picture. In particular, what made that such an unusual picture was that I was at the parade and there was a man standing behind me who was on stilts. So he was very distinctive. He was wearing stilts and he was dressed in a costume like the character Uncle Sam, who's a patriotic American character with a top hat and the red, white, and blue. And that was actually what was interesting about the image, not the fact that there was a smiling woman in it. And so the question is, how does, for example, that kind of error, the fact that something just wasn't mentioned at all, get factored into these confidence rates? And so I think as we decide what confidence rates are appropriate for certain situations, we also need to question, are these metrics themselves meaningful and capturing all of the relevant properties?
Super good point.
Yeah, that's a great point. That came up a lot in our study as well. This question of metrics and of specifically descriptiveness and contextual saliency of captions, just like you said. And I'm not sure that should be lumped in with accuracy. I mean, I think that's actually a really good question about what are these percentages that we're giving for accuracy or for reliability? What do they really mean?
Actually, this gets to a point, I think, one of the questions that's been asked had to do with, what are the important research problems for accessibility in the computer vision community? And I think this is one of those, is what are our metrics? And what are the metrics we're really trying to get at that's relevant for accessibility? But we can come back to that, and I'll actually leave that open for the panel, this question around what are the key issues in computer vision, because it actually ties into another question that I wanted to ask, which is, in all of the talks, computer vision's like a really critical piece of technology, but it's always combined with a lot of other technologies. And these are things like NLP, robotics, sensors, human in the loop and hybrid intelligence kinds of technologies. And so the questions here is, what do you think are the biggest challenges to integrating computer vision tech with other kinds of technologies? And what are we missing? And what's the low-hanging fruit here? So I'm gonna leave that. Let's actually start with Sherry on that one.
Let's see, what are the biggest challenges? I think that, to me, one of the main challenges is just in the process of doing research, looking at research as a social, and technology development as a social construct, because we are so siloed in our areas and in our communities. I mean, this is my first time doing anything with CVPR, I have to admit, but my sense from interacting with people who do computer vision is that generally speaking, the questions they start from are pretty narrowly focused on the computer vision, and they don't stem from the use case. And in real life, just like in all these applications that we're talking about, then all of these different sensory inputs and outputs are very much interconnected. They work together. So I think that one of the challenges is getting the AI community to think more about the use cases. This ties back to what we were talking about earlier in relation to context.
Anyone else?
Okay. So currently I'm working for the AI suitcase project. We really need to use all parts of AI technologies, computer vision, robotics, and so on. And the biggest challenge is how we combine, all aspects of component into one system. Like, so computer vision has its own open source component, but it is sometimes very difficult to integrate with other systems. So, from the real use case scenario or from real implementation perspective, there are a lot of development challenges here. Like when we use, GPU a lot, it's going to have a lot of heat, and it's not so good with a robot. So how we can reduce the GPU use, the usage of GPU. So there are a lot of other, challenges to make it into one system.
Mary, any thoughts?
Sure. I think that one of the challenges with integrating computer vision and other AI together would be actually around this issue of error and how to communicate error that we were talking about earlier, because now you have different confidence values and error rates from all the other parts of AI together, and you're gonna now kind of combine these to produce, again, to the end user, some prediction of error for this system overall. And so I think, again, this just adds to the importance of the question of how do we make sure that these confidence rates are meaningful when they're incorporating kind of a pipeline of many different sources of error combined together.
Anirudh?
Yeah, I think I can add to that. So I purposefully see research from the production lens from the get-go, and can it even be productionized? So before people start getting excited, I bring their hopes down. So for the longest time, it had been the compute available on the edge device where you want to run whatever you want to run. And luckily, I think since about 2015 onwards, on many of the mobile phones, the miniature GPUs that have started to come out have had like a 2x, like every 2 years, you'd basically see 2x, 1.5x, 2x, 1.56 increment in hardware. So that's good. The computer vision is great. You have rather miniature models, but NLP is actually pretty gigantic if you want to have those models like BERT. So luckily now what happens is iOS ships with the BERT model in the OS itself. So a developer doesn't actually have to ship a gigantic 1 GB model. You just have to share the last few layers. So this can be shipped rather easily. So that's kind of good. So performance getting good, and the size of the things you need to ship gets good. The one core problem, also now we had pruned BERT, which actually reduces the size of the state of the models really well. The key challenge that happens is that if you, let's say, are working on robotics, in training with particular data, you can test it out in a training testing pipeline, but with robotics, which is interacting in the real world, will it do exactly the thing that you intended to do during your training time? That is slightly harder to replicate. So going into a simulation to do that, as in like in a simulator, does help there.
I'm going to turn and ask a quick question that I see in the chat from the audience. And this is a question I think that says, I have a question for the panel. This is from Shana Kalbi. It says, various social media platforms have an automatic alt text generator for images, but often those captions lack detail. For example, if a German Shepherd dog is on the image, then it would output something like image may contain a dog. So instead, can we use hierarchical model, which can first detect there's a dog in the image and then make use of specific classifier, which can predict the exact breed of the dog in order to provide richer description of visually impaired users? Thoughts?
I think, oh, go ahead.
I'll just keep it really quick. Answer is yes. And the next answer is for production, all researchers have a little bit of skepticism, not researchers, but the people at the other end, like, will this be correct? So the point really raised in this question is that, hey, if we can do good for only 50% of the captions, let's do that. And for the rest 50%, let's just keep it high level. So if we have that sort of a hybrid approach where we are not going to give a caption for everyone, but for the things we are very specific we do, it should work. And actually that's how, even like in Seeing AI, we go about it.
Sherry?
Yeah, I was just going to say, I think that's a good idea. And that also makes me think of another direction to explore, which is enabling some interaction. Mary, I think this is something you've been talking about as well, which is looking at other models for delivering the information. So instead of just having, providing like a sentence, but allowing the user to also ask for more information or ask specific questions. So that could be one interesting way to present hierarchical information.
Yeah, absolutely. I totally agree, Sherry, that having interactive means of exploring automated image descriptions is a really promising direction to follow. Another thought I have just about the original question. So it's true that many social media, like Facebook, for instance, right now, gives these very high level automated tags, like I think it's a picture of food. And I think there's two issues there. So one is, for some of these, they're just giving those very vague descriptions because of maybe concerns about the quality of, the precision recall trade-offs in trying to be more specific, like, oh, it's pizza versus food. But another issue to consider is there's also social considerations that I know, that Xiaomei Wu from Facebook has talked about in their papers about that system. So for example, Facebook specifically avoids describing the perceived gender of people in the images. They just say it's a person rather than giving more detail like it's a man or it's a woman, because of a lot of concerns around accidentally misgendering someone and what the social ramifications of that are. Or for example, they don't choose to describe the perceived race or ethnicity of a person in an image, even though it may be possible to train a more detailed model to do that. And so I think that actually brings up a lot of important socio-technical questions about, what are the right kinds of details that these hierarchical models should be presenting to end users, versus are there some areas where maybe it's not considered desirable to present those details?
Well, so this gets to another question that I really wanted to ask the panel. Thank you, Mary, for that lovely into this, which is that systems that use computer vision out in the world, like in Facebook or like in the Suitcase or in Ira, these are going to contend with a lot of regulatory and ethics issues that they put issues of privacy, consent, or the kinds of information we're providing that are socially based on the part of the public or bystanders. And those are maybe in conflict with the rights of the people who may use the systems to work, play, get around, do whatever they want to do. So how should we think about these larger societal and ethical issues? And are there any promising technical or policy solutions that we might be looking for? Where should the research in this be going? So I'm going to start that with let's start with Chico.
That is, really great and tough questions. So actually, we need data. So currently, like at CMU, researchers have been, finding a good solution how we can collect the data. So if we want to go to a larger community, we cannot get consent from everybody. So sometimes, we try to create the route, with some, poster, like this area we are collecting the data. So if you don't want to attend, please don't use this corridor or something like that. So currently there, and from technically, we can, like a blur faces, not to identify who it is. So there are various, challenges and experimental ways to collect effective data. So, but for the I often think we may need some kind of special treatment. So like this year, we have conducted a massive survey how how people without disability think using the sensors or cameras for accessibility purposes. And the good thing was to help people with disabilities. A lot of people don't mind being collected the data. So I think we may need two approaches, Of course, one is generic approach to collect more data, and another is to collect data to specifically help people with disability.
Actually, can I make a comment on, I'll build on something Chicle mentioned. So I think Chicle mentioned that sometimes you enter like a corridor, say at Carnegie Mellon, that might have a sign up that says, don't enter this area if you don't want your data captured. And actually that reminds me of a comment that somebody else who was blind made to me once, how because they were blind, they were often not aware that sometimes when they enter spaces like at conferences or public events that have these signs up that say, by entering this space, you are agreeing that we're going to capture images of you that may be used for various purposes, including perhaps training AI data sets. So I think there's actually even just some interesting issues around how some of the current opt-out consent methods may not themselves be inclusive of people with different abilities. That's something to think about.
Yes, Anirudh.
I can go on this. As a person who has to fight with regulatory authorities, has gone to Washington, D.C. for basically proving why there needs to be regulation or not. So two quick stories. One is there's a user level, like the person who's using it, what is their consent. The other is the people around you. It's less consent and more about the question, which is acceptability. Yeah, I got confused there. So two quick stories. The one is, so IRA is available for free in like some 50 airports. So when you go to London Heathrow, JFK International, Seattle, someone who is blind can just download the app, lift the phone, and they will get this service where you press a button and it'll stream a camera view over to a remote professional agent. And this remote professional agent will describe them how to go about this particular airport, where they are in the airport, and how to go from this point to that point to that point. Also, the person is doing the things independently with their IRA agent. Now you can actually expect this, that in airports, there are certain places where you don't turn your camera on. You don't turn your camera on during the TSA, when you're going through the TSA screen check. That's like a policy. So when the service was announced, we realized the fact that TSA won't allow it. So when we showed what this technology can do for someone, they understood and they said, that's fine, go about this. And they just told their staff that it's fine, you will observe people using something like this, because they were balancing between the use case and the value that comes. The second quick note I wanted to make on policy, and this is especially about regulations. So if Apple decides, hey, let's say we take the best model that's going to be announced today, the best 3 models, and push it inside Siri or Cortana or Google Assistant, calling visual question answering. If you say, this is visual question answering, Mary, go about, no issues, people will use it. But if you say, this is visual question answering designed for the blind and low vision community, you'll first have to go to FDA, get a medical regulatory check. With the UK, with Australia, get the CE mark, and it's a world of pain. So the moment you say something is designed for people with a disability, that's where you basically are starting to go in the regulatory zone, even if it is not. And that's like the gray rule, which needs to be changed. So the way is, you say universal design, you say this is applicable to everyone, and it happens to benefit someone who is blind or low vision, and that's how you get about it.
You have any thoughts, Shiri, or?
I have a couple of thoughts. Going back to what Chieko was saying, I agree. And there has been research showing that people are more accepting of giving their data, or of allowing for certain things to happen when they know that it's specifically used in an assistive technology use case. So I think that one way to do this is to make that explicit, to make certain allowances for data to be captured if it's being used to provide equal access to information, right? I think that there's another model that we should probably all study, which is copyright laws, right? So generally speaking, you can't just take a book and like create a recording of it and distribute it to people because of copyright. But then for people who are blind, this is allowed. There's an exception. But the result of this exception is that it becomes very tricky and kind of difficult to actually acquire the content that's specifically made for blind people. It's only provided in certain formats, and you need to have certain types of equipment in order to access it. So that puts a burden on blind people, and it also marginalizes them. Again, we don't want to create a situation where people with disabilities are using specialized technology that's only designed for them. So there are many challenges in doing this, and I don't know what the right answer is, but one thing that I do know is that there should absolutely be people with disabilities represented in these regulatory bodies and the people making the rules, so that we can get this perspective as well, right? Because there's a tension of values here. On the one hand, we want equal access to information, but on the other hand, there are many people who understandably have concerns about privacy when their data is being captured, and all kinds of other concerns related to that.
Well, very cool. We have come to the end of our time. Unfortunately, this went really, really fast. And so I want to thank all of the panelists for their just their time and their thoughtful discussion, as well as the folks who were involved in this and provided some questions. And we weren't able to get to all the questions from the group and the folks, and I apologize for that. Partly that's me having an inability to read everything at the same time as I'm trying to pay attention to what folks are saying.
Can I make a quick suggestion, Ed?
Absolutely.
I would say if there are people who had additional questions that didn't get answered and want to continue the discussion, perhaps you could use Twitter and use the CVPR hashtag and mention the panelists you have questions for. And that way we can share the responses in a public forum on Twitter to any unanswered questions.
It's a fantastic idea.
Great idea.
Any final thoughts from anyone, the panelists, et cetera, before we close the session?
Ed, this is Abby Stengel. I'll just mention that we have an open discussion as well from 4:30 to 4:50 Pacific time.
Oh, very cool.
So those questions can be pulled there as well.
Very, very cool. All right. Well, I think with that, we will close this panel. And again, thank you all for your time and your energy and your sage wisdom. I appreciate it.
Thank you, Ed.
Take care.
Thanks, everyone.
Very much.